Today we're going to be talking about expressions and formulas, which you will see is the language of mathematics. You see, expressions have no equal symbol in them, and there are several important terms you're going to need to recognize. First, the word coefficient. The word coefficient refers to the number that sits in front of any letter or variable. Remember, the word exponent refers to the superscript numbers that tell us how many times a term multiplies by itself. The word term refers to a cluster of variables and coefficients that are linked together with symbols, such as the subtraction sign and the plus sign. Now, the constant is going to be a number that would have no variable or letter in it. And then the symbols and the operators that you will see will be subtraction and addition. Now, in this first expression, you're asked to substitute a given value in for each variable, that is the letter. So in this example, you have a -3 that you need to substitute into the problem everywhere there's an x. Now, when I substitute a value in, I normally use parentheses because I have found that that helps me keep the sign, the positive, negative, correct in the final answer. So as you see here, I have gone ahead and plugged in, substituted in -3 in place of x, and I put it in parentheses. This is especially helpful, the parentheses are, when you're using a calculator as well. So by the order of operations, I have to do the exponent first, and -3 times -3 is 9. Now that 9 will need to be multiplied by that coefficient -4, giving me -36. Then I have the -3 and the 6 next door to that, and I multiply those. Positive times negative would be -18. Then I just bring down the constant, which is that number on the end, bring it straight down so I can total this up now. All three of these are negatives, so I would simply go ahead and add them together, and my answer will also be negative. So this is a -63. Correct answer is B. Now in this example, I'm given a formula. Now a formula does indeed have the plus sign in it a lot of times, but what you're trying to solve or work out would be the expression part on the right hand side. This formula is a profit formula, like used in a lot of different businesses. This profit formula is devised for a specific shoe shining business. Yes, there are some big major cities that still do have shoe shiners. And so here we have 500 pairs of shoes, and X is what is represented for those shoes. So I substitute in the 500 for the X. So I take and I substitute that in again. You may use your calculator if you wish, and you multiply the 0.6 coefficient times the 500 shoes, and then you minus 53. That gives me 247 would be the profit. So my correct answer is A. Now in this formula, I have a scientific experiment going on, and this is the formula that would model that particular experiment. Apparently there's going to be a catalyst that's added for a chemical reaction to occur. So the amount of the catalyst is going to be the C, and this A, it says, represents the final amount that is produced in this experiment. So the question is, how much of this compound is produced when you have 700 milligrams of the catalyst? So the 700 is the C. What I will do is substitute in 700 in place of C, and you can multiply that either with or without your calculator. And you end up with 16.34. And that would be in grams. So in the final end, that reaction produces 16.34 grams. Here we have a forensic scientist who has come up with a formula to determine the height of a person. In particular, this is the height for a man, because generally men and women have different patterns for height. And this is used in forensics when just a random bone is found. This particular formula would be applied if a person found a human femur bone that they identified as male. And so we want to find the height of that person. Well, if we take, and the centimeters would be the femur bone length, so I plug in the 64 for the F, which represents the femur. And again, this is given in centimeters, which you may not be as familiar with as inches and feet in our country. And I would go ahead and calculate this. Many scientific formulas do indeed use the metric system. And this would be 212.45, but again, that's in centimeters. And there would take approximately 2.54 centimeters to equal 1 inch. So if a scientist wanted to tell a police officer, for instance, how tall this person were, most of the time they'd convert that to feet and inches. Now here we have a satellite, and it's going to be modeled by this particular formula, P equals 6t squared plus 30. And it says that we want to use this model to interpret t equals 11. T is normally time after a model shoots off. So I'm going to go ahead and substitute in the t. So when I do that, that 11 squared is 121, and 6 times the 121 gives me 726 plus the 30, and that would be 756. So P here is going to be 756. My correct answer would have to have T is 11 and P is 756. So that would be answer choice D. Now here is an example of a problem that used a formula or an expression to come up with this chart. Here's a chart of the students that are studying Native American studies, and they're majoring that at a local state university. And our question is going to be estimate the number of Native American study majors there were in year 5. The years would be down here across the bottom, and then these would be the students on the vertical side. So if we're looking at year 5, you would simply need to pinpoint that year and determine how many students that would represent. Since that is midway of 80 and 100, we would approximate that to be 90, which is answer A. Now we have a formula for calculating Celsius and Fahrenheit temperature. Here we want to convert from Fahrenheit to Celsius. So we take our 23 degrees Fahrenheit, which is very cold, that's below freezing for us, but we want to convert that to Celsius. Now Celsius temperature is used all around the world where the metric system is used, and it's also used in a lot of sciences. So if I work my parentheses first, 23 subtract 32 will give me a -9 in parentheses. And you could put that in a calculator, but if you recall, -9 is a whole number, and I could cross cancel that, and then 5 times that -1 is a -5. So the degree for Celsius would be -5. That would be equivalent to our 23 degrees Fahrenheit. Now, when it comes to expressions, you need to remember that you can combine like terms and expressions. Like terms have the same letter and have the same exponent. For instance, 6x minus 2x equals 4x. We combine the coefficient and bring over the x. In the second example, 8z minus 2z is equal to 6z. And then the 8 and the 6 would be added together to be 14. Do not add the 6 and the 14 because the 6 has the z and 14 does not. Now you can also use what we call the distributive property to simplify expressions. The distributive property simply takes the number on the outside of the parentheses and it multiplies times each term inside the parentheses. So if I have 9, I multiply that times x and y. There's really nothing to multiply here, so I simply call that negative 9x, negative 9y. The sign carries through. On the second example, negative 2 times 5 and negative 2 times 9. Well, negative 2 times 5 does equal negative 10x, and negative 2 times 9 is negative 18. Here is another algebraic expression. I would have to multiply by the negative 5 out in front to get negative 10x and positive 40. However, I do not multiply these terms in the back because they are not in parentheses. Just bring those down into the expression and combine the like terms. The like terms would be the negative 10x and the negative 4x, which is negative 14x. Then we would have the 40 and the 7, both positive, so that would be 47. And that gives me the final answer.